Hi guys, it's Mrs. Glenn. Welcome to the 2-1 video and Bellwork. So you're going to watch this video and take notes in your notebook, so make sure you put your Bellwork in your Bellwork and then switch to the notebook when we go to 2-1. So you can pause as needed, so just pause the video as you go along so you can copy down the notes. Alright, let's get started. So first question on your Bellwork is number 3, so go ahead and pause the video and try to do number 3 on your own, and then come back and check your answer, and remember to fix your answer if you have a mistake. So go ahead and pause the video now. Alright, welcome back. So the number 3 says you are adding orange juice to a 10-liter capacity jar. The equation 3x minus 2y equals -5 relates the amount of juice y in liters with the number of minutes x you add juice. How much juice was in the jar to start? At what rate is the jar filled? So in order to calculate that, you have to put the equation they gave you into slope-intercept form, and all that means is to make sure you solve for y, and then you'll get y equals the slope times x plus b, and b is your y-intercept. So I'm going to solve for y. First thing to do is subtract 3x, then divide by -2y on everything, and I get y equals 3/2 x plus 5 over 2. And I'm going to switch that to 2.5 just because we're talking about liters and we don't use fractions when we're talking about liters. So it says how much did you have at start? So that is the y-intercept, because the y-intercept is your starting value of any situation that you're talking about. So the starting value is 2.5, which means there were 2.5 liters in the jar to begin with before she started adding juice. And that's the answer for number 3. All right, number 4, go ahead and pause this one and try to do this problem on your own, and then come back and check your answers. All right, welcome back. Number 4, Martin bikes at a constant speed to a finish line that is 15 miles away. After 20 minutes, he's 10 miles from the finish line. After 30 minutes, he's 7.5 miles. If the graph shows that his distance y from the finish line in miles after x minutes, what is the slope of the graph and what does it represent? All right, so I like to make a table when they have this kind of information so that I can see what they're talking about. So the first thing they told us was that the race was 15 miles. So before he even starts, he has 15 miles to run. And then when he gets 20 minutes in, he's 10 miles away. And then when he gets 30 minutes in, he's 7.5 miles away. So you can see as the time is increasing, his distance to the finish line is decreasing. So now it wants us to calculate what the slope is. So remember, your slope formula is y2 minus y1 over x2 minus x1. And all that means is we can make these values that you have in the graph actual points. So what I'm talking about is if we were to graph the first one, you'd have 0, 15, and the second one would be 20, 10, and the last one would be 30, 7.5. So you can pick any two of those and plug them into where they go in the slope formula. So when they're referring to y2 and y1 and x2 and x1, they're just talking about the first point that you pick and then the second point that you pick. So if we say that our first point is this one, these will be our x1 and y1s. So this is x1 and this is y1, and then down here would be your x2 and y2. So then you go ahead and plug those values in. So we have 7.5 minus 10 and 30 minus 20. And then you just subtract and divide. So 7.5 minus 10 is -2.5, and 30 minus 20 is 10. And when you divide, you get -0.25. Looking in the answer choices, the only answer that has a -0.25 is C. And that means the rate at which Martin's distance from the finish line changes per minute. So -0.25 miles every minute that he's running. All right, so let's get started on 2-1. This is model and discuss. Go ahead and put the date, 9/23/20. All right, so Elena wants to buy a $360 bike. She is considering 2 payment options. The image shows option A, which consists of making an initial down payment, then smaller equal-sized weekly payments. Option B consists of making 6 equal payments over 6 weeks. So what factors should Alani take into consideration before deciding between option A and option B? Well, anytime you take out a loan of any kind, you have to think about your regular income and your expenses and whether or not you can afford the item that you want to take a loan out for. So that's the first thing that she needs to think about. And then B says, suppose Alani could modify option A and still pay off the bike in 5 weeks. Describe the relationship between the down payment and the weekly payments. So first thing is if she makes a larger down payment, she'll have smaller weekly payments. And if she makes a smaller down payment, she'll have a larger weekly payments. So down payment is an amount that you can put down to try to take away the amount that you're taking a loan for so that you don't have to pay interest on such a big amount. So if you put a bigger down payment down, then you have smaller payments because you're not loaning as much. And then vice versa, if you put a smaller down payment down, you're going to have to take a bigger loan, which means you have a larger weekly payment. All right, so let's take a look at graphing. So we're going to graph our slope-intercept equations. So first thing you want to do is remember your slope-intercept form of y equals mx plus b, where m is your slope and b is your y-intercept. And the first thing you do is you always plot the y-intercept because that's your starting value. And our y-intercept in this equation is 2. So on the number line, or on the quadratic plane, you're going to plot 2. And then looking at our slope is 4 over 5, which means we go up 4, 1, 2, 3, 4, and to the right 5, 1, 2, 3, 4, 5, and put a point there. Last step is just draw the line between the 2 points. So we draw our line and we're done. Sometimes our graphs don't fit exactly the problem we are trying to graph, and that's perfectly okay. Just make sure you try to estimate as best as you can, where that point would be. All right, next problem. So sketch the graph y equals negative 3 over 4x. So I want to emphasize that the negative always goes to the top and the bottom will always go to the right. So your top number will either go up or down depending on if it's positive or negative, and the bottom number always goes to the right. So if you think about it like this, if you want to be right, go right. So if you can say it like that. So again, we're going to plot our y-intercept. So our y-intercept is negative 5 right here. And we're going to use our slope of negative 3, which means we go down 3. 1, 2, 3. And if we want to go right, so we're going to go 1, 2, 3, 4, because that's our denominator. And then we plot a point there. You do not need these little dashes on your graph. I only put them there just so that you can see where I went. So I'm going to get rid of those and then draw the line. And that would be what our line looks like. And that makes sense because when you're looking at a line, if the line is going down, so pretend like there's a car on this line. I'm just going to draw a really bad car, but you get my point. So if there's a car on this line and it's going downhill, that means there's a negative slope. And if the car is going upright, like our last problem, let me get back to the last one we did. So you see how the line is going up? So we have a car again, and he's going up the hill. That means there's a positive slope. So if it's going down, it's a negative slope, and if it's going up, it's a positive slope. All right, let's go to the next problem. So we have an example number 2. What is the equation of the line in slope-intercept form? So remember our slope-intercept form is y equals mx plus b. So we first have to plot the y-intercept. So looking at the graph, I'm going to circle the y-intercept is at 1. So I write positive 1. And then from the y-intercept, how do I get to the second point? Well, that means I'm going to go down 1, down 2, down 3. So my top number of the fraction will be negative 3 because I went down. And then to the right 4. 1, 2, 3, 4. And remember, the right is always positive, so it's a positive 4. Then I just plot the x next to it and the y. And if you're wondering why the y and the x are always in the equation, it's because in order to find any point on the line, you can plug in an x value and it'll tell you what the y value is. So x and y will always be in the equation. The only thing that changes is the slope and the y-intercept. All right, so next problem is a try it, which means you're going to pause this video and try doing this problem on your own. I just showed you how to do a couple different graphs, so you should be able to try it on your own now. So go ahead and pause the video and try to write the equation to this graph. All right, let's check your work. So we're going to start with our y-intercept. So I can see that's at -2. Then I'm going to go up 1, up 2. So our top number is going to be a 2. Then I'm going to go to the right, 1, 2, 3. So our bottom number is a 3. And then I put my x and my y, and I have my answer. So if you got that one right, good job. If you didn't, go back and check to see what you did wrong. And that is the end of 2-1 for today. We will finish 2-1 tomorrow, and I hope you have a great rest of your day.